I think I'm live now. Can you confirm if audio, video, and everything is fine before we get started for today? Hello, hello. Hello, hello. Can anyone confirm if my audio, video, and everything is fine before we get started? So yeah, I think the agenda for today would definitely be first for problems, and then I will look at other implementations on E and if they make sense to me, I will explain how to solve them. If they do not make sense to me, then probably I will end up speaking. So let's get started. I will start from problem A. So like the first problem was initially you have a coin with value V. You can perform the following operation any number of times. Transform one coin with value X where X is greater than 3 into two coins of value X by 4. And this was the problem statement. Let me fetch. And yeah, like the main idea over here was you notice like the two coins you create has the same value. So you can keep doing same kinds of operations and keep doubling the values you have. Okay, hello, hello. Am I audible or not? I think now the audio should be fine. Hello, hello. I think now everything should be fine. I'm hopeful. Let's just confirm before we get started. Okay, yeah. So, like the first problem says we have a coin X and we can transform it into two coins of value X by 4. And we have to find maximum number of coins after we keep doing the operations on the given value X. And yeah, so like probably let's look at 16. How does operations happen over here? So, like the main idea here is like, for example, if you look at 16, we will get two coins of value 4 and 4, and then we can do operations again to get four coins of value 1 and 1. So the idea is like keep dividing by 4 as long as your X is greater than 1. If X is greater than while if X is greater than 3, you multiply count into 2, like you double all the coins you have and you divide X by 4, and this was essentially the solution for this problem. And looking at the implementation, yeah, like order 1, I'm not really sure. Like there can be some bitwise manipulations that can do it. Most likely, any library function you are using may not support this. So multiply count by 2, keep dividing by 4 as long as current value is greater than 3, and print whatever the count here. So that was problem 1. I will move to problem B. Ahem wrote the digit d on board exactly n factorial times in a row. So he got d n factorial times. Now he is curious which odd digit from 1 to 9 divide the numbers written on the board. So like for example, let's take some of the samples here. Let's say if d is 6 and n is 5, then it means we have a number which has 6 is 6 120 times, which is around 5 factorial. And now we have to find it for given all n and d. The main idea I had was like let's look at different divisibility rules we have. 1 divides all the numbers. All numbers. 3 divide if sum of digits is divisible by 3. And if you look at sum of digits would be d into n factorial. So either d should be 3 or n factorial should be 3, which happens when n is greater than equal to 3. Now, like it's probably casework for all the values of 1, 3, 5, 7, 9. Now, a number is divisible by 5 if it ends with 5. Last digit is 5 or 0. So we can just check if d is 5, print 5, otherwise do not print anything. Let's forget about 7 now first. Let's look at 9 again. A number is divisible by 9 if d into n factorial is divisible by 9. And you see like 6 factorial and greater than is always divisible by 9. So we can directly print yes here. Otherwise, if it's 3 factorial, then we can get 3 from here and d should also divide 3 here. Or you can just brute force it by finding factorial and multiplying it by d also works. Then check like if n is greater than equal to 6, then you have 6 factorial which is divisible by 9. So you just print yes over there. Otherwise, you keep checking the value for 9 as well. Similar thing you can do for 7 as well. Or probably like I have one more strong result here. Like the idea is for all n greater than equal to 6, if like let's say the answer will always be same irrespective of whatever value you have. Like you can just keep u equal n equal to minimum of 6 comma n and then just solve this problem. That would also do the job for you. Like you can just replace n equal to minimum of 6 comma n and then just try to brute force the value you have by keep finding all the factors. That should also solve the job. This looks simple. Like you see like for 1 it doesn't really matter what the value of n is. For 5 also it does not matter what the value of n is. For 3 you know that when n is greater than equal to 6, n factorial divides 6. So this will always be 0 here. And same goes for 9 as well. Like when n is greater than equal to 6, 9 will divide 6 factorial. So the answer will always be yes. The problem remains how to solve for 7. The idea here is like if we have n 6 times 1, 2, 3, 4, 5, 6. This number is divisible by 7. Like if you look at this, like how did I found? I have manually looked at the cases here. Like this is divisible by 7. So whenever like n factorial is greater than equal to 6, then the answer is always yes for 7 as well. So you have to only check for cases when n factorial is less than equal to 6 again. Yes, n factorial, like if d is divisible by 7 also, then also the answer is yes. So like basically our problem reduces to like we can take input, then we can replace n of minimum n comma 6 and try to check if this works or not. And we can pre-compute answers for all d greater than equal to 1 and n greater than equal to 6. Like this is probably the lazy way to do this problem. Like the lazy way to do this problem is just find answers for all d between 1 and 9 and all n between 1 and 6. You replace n equal to minimum of n comma 6 and print whatever value you have. No, like 6 minimum with 3 will not work. The main observation here was like when you have 1 repeated 6 times, then that divides 7. And like so, for example, 1 6 time is divisible by 7. 12 times is also would be divisible by 7. 12, 18, anything, any multiple of 6, this will definitely be divisible by 7. And the idea was like whenever n is greater than equal to 6, n is greater than equal to 3, n factorial is divisible by 6. And that's why we can say like whenever n is greater than equal to 3, we can just print yes for 7. If n is 2 or 1, then we should look at the value of d to find whether it's divisible by 7 or not. If we have like for example 7 and 1 where d is 7 and 1, then we should print just 1 and 7. No, like okay, this is an important question. Like was divisibility by 7 just pure intuition? Like one thing I knew was like this is probably this is problem B, so pattern should start repeating after some point of time. So I just looked at like n when divided by 1 is divisible by 7, 11, 111, 111. I just checked these 6 values. I found like when n 1 is repeated 6 times, this is divisible by 7. Then I looked at 1 repeated 7, 8, 9, 10, 11, 12, up to 14 times. Like, and there that's where I found like it's divisible when it's multiple of 6, it's divisible by 7. Once you know like once you know like 1, 2, 3, 4, 5, 6, this is divisible by 7, then now it's easy to prove for all the multiples of 6. You can write this as 10 to the power probably say 0 plus 10 to the power 6 plus 10 to the power 12, like any further whenever the number of digits are multiple of 6, you can always write it like this, and this part will always be divisible by 7, so whole number should be divisible by 7. And that was essentially the idea over here. And probably if you want to look at the casework, like it was a lot of if else. So like 1 is always divisible irrespective of the numbers. For 3 we should check multiple, like d into n factorial should be divisible by 7. So if d is divisible by 3, we can print 3. Or if n is greater than equal to 3, then n factorial is also divisible by 3. So we can just print 3. For 5, the last digit should be 0 or 5. So if d is multiple by 5, this should be good. For 7, the idea was like either n factorial should be divisible by 6, which happens when n is greater than equal to 3, or d should be divisible by 7, which happens when d is 7. So you can print 3 out 7. For the 9, the idea was same. If n is greater than equal to 6, n factorial is divisible by 9. Like we need sum of digits, right? Again, if n is greater than equal to 6, then d into n factorial would be sum of digit and that would be divisible by 9. Otherwise, if n is greater than equal to 3, then you can get 1 3 from n factorial and one probably you need one more 3 from d. So this would be the case necessary condition here. Otherwise, like d should be divisible by 9. So you print 9. Number of same digits d is divisible by 7 if we create even number of pairs of size 3. Okay, no, I am not sure. So this was essentially the casework here. Any questions, anyone? And like another lazy way to probably do it over here is probably to notice like whenever, like now if I look at these cases, whenever n is greater than equal to 6, the answer does not changes here. Answer does not changes here as well. Answer does not changes here as well. Answer does not changes here as well. Like that's why you can probably replace n equal to minimum of n comma 6 and call it a day as well. Like that was another idea. So any questions, anyone on problem B? Like the only reason I checked when the pattern starts repeating for 7 was I knew it's problem B, so there must be a pattern here. So I just started looking at some patterns here. Yes, like the hard part of the problem was 7 only. Like rating changes will probably appear in next 12 to 24 hours. I think if we are good with problem B, I will move to problem C. Any questions, anyone? Okay, I will move to problem C. Thanks, everyone. Sum of segments. You are given an array A of n digits where all the element except for at most 1 are equal to -1 or 0. The remaining element x satisfies x is between -10 to the power 9 to 10 to the power 9. Find all the possible sum of arrays of A, including empty subarray, whose sum is defined as 0. In other words, find all integers x such that array A has at least one subarray with sum equal to x. Subarray is continuous segment of all the arrays. Output these sums in ascending order. Each sum should be printed only once, even if it's achieved by multiple subarrays. So there are multiple ways to do it, and a lot of time I say like you should solve problems because that makes you a bit faster. So one lazy way to do this problem is like you pretty much use whatever code you have written in yesterday's div 3. So you should check out my yesterday's video and see how did I solve this problem. Same idea can be used in this C problem as well. So that is one way to do it, like exact same idea. And like I will explain it again, but essentially the problem statement was same as this. So like let's look at the different ways on how this array can be divided. Okay, so our array looks like this. We have some values 1, -1, -1, 1, -1. Then there is one big element x. And then we have again 1, -1, -1, 1, -1, 1, 1. Now, like, let's probably focus on this part. Let's find the minimum sum in this range and maximum sum in this range. Like that you can probably do, like the idea would be like if you know prefix sum, then sum of numbers from L to R is and using this formula like you can find sum of all the values you have. And the main idea observation here was since whatever the minimum value is, if you look at the nearby value, it must be 1. Like the idea was all the values between minimum and max would be achievable here. And the key reason was like the values are continuous. You start with 0 here, and then you add some value by 1 or you remove value by 1. So if you try to pick any element. Then if you pick this as the starting element L, then if you try to plot sum of values from here, like this will always increase by 1 or minus 1. So if you know the minimum and maximum sum, then all the values between minimum and maximum would be achievable by just taking this array. Any questions, anyone, on this part first before I move on to the second part? Longest consecutive 1 and longest consecutive minus 1 work. No, that should not work. Like for example, look at minus 1, minus 1, 1, minus 1, minus 1. The minimum sum you can get is minus 3, and maximum sum you can get is 1. And if you look at longest consecutive one, which is minus 2. Yes, I mean min and max sub-array sum for all the parts between by just looking at values here. You can do the same for this part as well. Find minimum maximum possible sum by looking at this value here. Now the next part is what happens when we take x as one of the input. Like I think we have now covered all the possible arrays which does not include x. Now we should probably look at x as well. Let's take this x and then look at 1, minus 1, minus 1, 1, 1, 1, minus 1, 1, minus 1, 1, 1, something like that. So we will take x. Now we need to find maximum possible sum which ends at this, and minimum sum that ends here. Like you can probably find minimum prefix sum here and maximum prefix sum here, kind of thing. Like Kden does not work. And similarly, you should find maximum and minimum sum that starts here. And the idea is like, let's say here the range of numbers is L1 to R1. Here the range of number is L2 to R2. Then minimum sum you can get by including x, and some part from here and some part from here would be x plus L1 plus L2. This would be the minimum you can get. And maximum you can get would be x plus R1 plus R2. And the key observation was all the numbers in this range would also be achievable. And this was essentially the solution for this problem. Okay, can I tell how to find min and max using prefix sum? Okay, yeah, definitely I will do. First, any questions here? Like if you are able to find min and max values, then this is how you should find all the ranges here. If we are clear on that, then I can also say like how do you find min and max sum on an array which contains only 1 and minus 1 here. Yeah, like one solution is like, now I see someone mentioned cadence algorithm. Yeah, like that is definitely doable. Like you can definitely look at cadence algorithm to find max sum, multiply all the values by minus 1 to get minimum cadence sum as well. Like multiplying all minus 1 and trying to find max sum is equal to minimum possible sum multiplied by minus 1. Okay, how equal to L1 plus L2x? Like the idea is you have to definitely take this x. Now you try to get minimum sum from this side and minimum sum from this side. And if all the sums here, all the values here which starts from here is from between L1 R1, then minimum value you can get from here is L1. And similarly, maximum value you can get here would be L2. And this will always be the case that L1 minus 1 would always be less than equal to 0. And R1 would always be greater than equal to 0. Because not taking anything just means you get 0, 0. Okay, so I think we have two parts here. How to find minimum and maximum sum in a range, and why all possible values are possible. Like let's say I have this array A1, A2, A3, A4, A5, A6. And let's say all the values are 1 or -1. And like let's say I start writing values from here. Like let me just give me an array of 1 and -1 ones. So I will show you around. Give me any array of 1 and -1. -1, 1, 1, 1, -1, -1. So now let's say like if we don't take anything, our sum is 0. If we take this, our sum becomes -1. If we also take this, our sum becomes 0. If we take this, our sum becomes 1. If we take this, our sum becomes 1. If we take this, our sum becomes 0. If we take this, our sum becomes -1 again. Now you see like maximum value here was 1, minimum value here was -1. And to reach from max to min here, you have to keep subtracting by -1 always. Like whenever you do +1, you will have to do -1 at some point of time again. And that's how you will end up with all the values between maximum and minimum. Like the idea is like let's say this array has minimum sum. If you extend it by 1, you will increase that sum by 1. If you extend on this side, you will increase that value by 1. And whenever you decrease, you will again keep increasing by 1. And you will end up, let's say, something like this. And let's say you came up with this as the max sum. If you extend it on left side, you will decrease that value by -1. If you decrease this side, you will decrease that value by -1. That's the idea. Like if you start with some range, if you extend it, either you will increase it by 1 or you will decrease it by 1. And if you know like what is the minimum value you can get, what is the maximum value you can get, you take min, increase on one of the side, you will get min +1. Increase it on the other side, you will get min +2, and you can keep doing it. And like probably the mathematical term for this is like it's a continuous function here with respect to integers. And that's why you will keep getting all the ranges between minimum and maximum. That was the first question. I think I will jump on to like how do we find minimum and maximum for the given value. But before that, any question, anyone? Yes, like if we get -3, then everything between -1 and -3 would be taken. Because to get -3, you will have to first get -2 and then subtract 1 there. Similarly, if you get 5, you will have to first get 4 from somewhere and then you add +1 to get 5 there. And like minimum will be always be less than equal to 0 and maximum will always be greater than equal to 0 when you are not in, if you are looking at array of anything which is 1 and -1. Because not taking anything is 0. Okay, now how do we find max and min sum there? Like probably let's revisit prefix sum once. Let's say we have this array a1, a2, a3. You can definitely use cadence algorithm there, a5, a6, so on. And like let's take value here 1, 4, 5, 10, 6, 2. Then we define a prefix sum array where value of pi is sum of numbers up to ai. Up to ai. So like our p array would be p 0, 1, 5, 10, 20, 26, 28. Now let's say we want to find sum of values in this range. What we can do is like we can write this a3 plus a4 plus a5 as a1 plus a2 minus a1 minus a2. And if you essentially notice, this is equal to sum of first 5 terms, which is p5. This is sum of first 2 term, which is p2. So our a3 plus a4 plus a5 is essentially p5 minus p2. Then the idea is like you create this prefix array when you want to find maximum sum that ends at some r. Then you find like minimum value of this prefix sum p0 up to pr, and pr minus minimum of whatever comes here will give you the max value. And pl minus max of whatever comes here will give you min value. You can use this ones. Like you can definitely use cadence algorithm, but you will be stuck on the part when you have to include x. Because here you have to find maximum minimum sum that starts from here and maximum minimum sum that starts from here. That you cannot possibly do it with cadence algorithm. You will have to use some prefix sum idea there. Like you cannot apply a binary search here. And like now I will also answer like why it's similar to yesterday's problem F. In yesterday's problem F, like the solution essentially was you brute force the idea and you realize like if you maintain the intervals where the joker can be, then there are not more than three different intervals here. And like the same idea will in fact hold true here as well. Like if you maintain the answers and you maintain the continuous range of answers, here also you will not have more than three different answers at any point of time. And essentially that was the solution here. I will probably jump onto my code as well. So I have this function which gets range for all the values which are in starting, which includes 1 and -1. So I tried with minimum prefix value this, maximum prefix value this, current value prefix value this. And minimum and maximum you have got so far is this. And now this gives you like maximum possible sum and minimum possible sum before the first x appears. So that's how I found it starting, then reverse the array to found it the other way as well. And now I have inserted these values, all the values between this in the answer I have. Now I looked at the middle value, with the value which is not equal to x, and its index as well. Index was not required, but that's fine. Now the idea was like if there exists a middlemost value, then you find maximum sum which starts from the x and minimum sum which starts from the x. Reverse the array to get the maximum minimum sum for the other side as well. And this was the function which first finds where value where x appears, and then it starts from 0 and keeps looking at minimum and maximum prefix sums from that side. Or you can probably keep it this as well. And like the idea was I can use the same function by reversing the array only. Any questions anyone on problem C before we move to problem D? Okay, I think I will move to problem D then. It says problem about GCD. Given three integers L R G, find two integers A and B such that their greatest common divisor equals G and distance A between them is maximized. And if there are multiple pairs where distance is same, then we should find the value which is minimum A. And if no such value exists, we should print -1, -1. So there are multiple ideas here. Like one short and simple idea is like let's first forget about G. Let's first solve this problem for g equal to 1. And then we will solve it for other g here. So now we have two ranges L to R. We should find a pair x comma y such that GCD of x comma y is 1 and the difference of x minus y is maximum, and if there are multiple values then x is minimum taken. The crux of this problem was you just look at all the values between L and L plus 30, take x from this range and y from this range R minus 30 to R, and just find the pair in this range and that should be enough. I will probably try to prove it now, but essentially this was the solution. If you want the answer with GCD 1, then you just look at value between L and L plus 30 and R minus 30 to R. Like 30 is kind of magical number. Like my main idea was like I look at sum of smallest prime factor. How many such prime factors appear when the value becomes 10 to the power 18? And I haven't really checked it, but my claim was sum of product of first 30 primes is greater than 30. Okay, like one thing was I have used this observation multiple times. Another observation was like, let's say I have this number 2 into 3 into 5 into 7 and like this. I can replace all of these numbers by 4. And let's say I have k such numbers. Then this value is definitely 2 into 3 into 4 to the power k. This value is greater than this value. And if this should be less than equal to 10 to the power 18, then k is roughly equal to log 10 to the power 18 by log 4 with base 4. You can in fact even prove a stronger result, like the actual value can be less than probably around 20 or whatever you have. But like I just took 30 as a rough estimate because constraints were enough to allow 30 checking 30 into 30 pairs. So like basically if you look at first 30 numbers, if you look at any consecutive 30 numbers, or another way to say is if you have let's say value fixed value y, there will for any integer I between I to I plus 30, there will exist one number which has GCD 1 with this y. And probably the other way you can probably do is like you fix distance first. Like for example, you can start with distance equal to y minus x. You run a while loop where d you keep doing d minus minus, and then you start with x plus 1 up to x plus d. And whenever you find the first pair in a for loop like this, you print that. You don't even need 30, you can just directly brute force it like this. Yeah, like the main idea is like this will not really, because what I have proved is whenever you do 30 iterations on this loop, on 30th iteration, you will definitely find one pair with GCD1 on this loop. Right now, remember that I am solving for GCD equal to one case, not the other case. Like I am just solving for G equal to 1 right now, not the other cases. And the strong result I have proved is like when you look at first 30 differences, you will definitely find one pair with GCD1 here. Any questions on this? How do we know 30? Like my idea was, like, let's look at first product of first k prime numbers. If whatever value we want to check is less than product of this first k prime numbers, then there would be one number which will not be divisible by one of the primes here. And if I look at, I can replace all the primes which are more than 4 by just 4 years. So this product would be more than 2 into 3 into whatever values k I had over here. And if this is itself is greater than 10 to the power 18, then this product would also be greater than equal to 10 to the power 18. And 2 into 3 into 4 to the power k greater than equal to 10 to the power 18. Like you can probably divide by 6 and take log on the both sides. So you will get k around log 4 of 10 to the power 18, which is around 30 here. This 30 is a very rough estimate. Actual number can be much smaller here. Like in fact, we can in fact even check for that value as well. $29. Okay, now I am curious why 30 works. But my idea was first 30 primes, not the 30th integer. 29, 33, 34, 37, 41, 43, 45, 47, 51, 53. Okay, so instead of 30, if we replace it by 60, we should definitely be good. Like first 30 primes is what I was looking for, and first 30 primes, 30th prime probably is 60 here. So instead of 30, if I say we replace it by 60, we should definitely be good here. And the crux was like you can probably try to look at the value you may like the actual bound can that will definitely be lower than 60 as well, whatever value we have. So like the code I have written might be hackable, but I'm not sure. Another question is how to solve g greater than 1. The idea is we find one L new, which is L divided by G, and take seal here. And we find R new, which is R divided by G. We take floor here. And we solve with L new, R new, and GCD1. Whatever answer we find, we multiply it by G and call it a day. And essentially that was the idea. Like now for this L new, R new, try to find the value which is greater than G. And like probably the other way to look at is we can probably look at the GCD of first 30 numbers. That can also do the job for you. No, like I don't say, what I am saying is for every number y, there is a number x between I and I plus 30 for whatever I you have, such that GCD of x comma y would be 1. And what I have actually seen is instead of 30, it's 60. But probably I can look at LCM of first 30 numbers. Like if you like Okay, I can just write a Python code to check it. Okay, first 30 does not work. Does 41? No, like probably I think instead of 30, I should have said 50. Like probably the actual bound can be lower and it can be potentially possible to prove it. Hi Utkarsh, but essentially that was the idea over here. Like I doubt L plus 20 and minus 20 would be possible to hack here, but essentially that was the idea. Like the main crux of this problem was you just iterate in the decreasing order of d and increasing order of x and try out all the pairs until you find one or you run out of pairs. Okay, any example one? L r L plus 1 r L comma r minus 1 are all greater than 1. Okay, I doubt such pair exists, but I can try for it. Yeah, like that was the intuition I had. Like when I have coded this problem, my idea was like this loop should not have more than 2 3 iterations, but I did not try to prove it formally actually. Hmm. So like the stronger claim someone is claiming is LR, L minus 1 R, and L comma R minus 1. One of them should have GCD 1. And it might actually be possible. Like I won't be surprised on this one. Mm, like I will probably spend 2 minutes on this one. If I don't fight, then I will probably leave it. LR L plus 1 R L R minus 1. So like GCD of all of these numbers would definitely be 1 here, right? Like we can definitely make these pairs wrong, but in that case, this might not be true. Yeah, I doubt. Like actually, like the strong result now we have is like we should just look at these 3 pairs and print the answer here. Like probably like you would be able to see other solution later on, but essentially that was the idea. Like that is in fact a bit difficult to prove, but might work as well. So any question anyone has on problem D before we move on to problem E? Like for problem E, I will have to probably look at someone else's solution because in contest I did not solve E and F. So any ideas, anyone like how did they solve problem E? Okay, interesting one. Okay, like conclusion of D was you just look at pairs in this range L plus 30 and R minus 30 to R. Like for G equal to 1, you will definitely find one pair where GCD is 1. if such a range exists. And the idea to solve for g greater than 1 was GCD greater than 1 was you create new range. L new is L by G taken seal, and R new is R by G take floor. You solve for this L new, R new, and GCD1. Whatever answer you get, you multiply it by G. And like this was the conclusion here. And for 30 was a random number. Like I can in fact actually prove that like for 50 we can definitely get such pair. Like my intuition was like if I look at any number and if I look at the product of first 30 number, my intuition was product of first 30 number might be less than 10 to the power 18, more than 10 to the power 18. In that case, the idea is like if you basically you look at LCM of I up to I plus 30, my intuition was this should be greater than equal to 10 to the power 18, which is not actually true by the way. The product of first 50 continuous number would be greater than 10 to the power 18. So instead of 30, you solve it for 50, you will definitely get an answer. And someone has just mentioned LR, L minus 1 R, and L plus 1 R, and L comma minus 1. Like in fact, actually, it can be probably sufficient to just check these three values here for GCD equal to 1, but I haven't really tried proving it if just these three values would be sufficient. And essentially, this was the conclusion here. So, any questions, anyone on problem D? Any ideas, anyone on how did they solve problem E? Like you would be able to look at someone else submission later on. So for now, it's showing NA. You can just wait for some time. Matrix transformation. You are given two matrices A and B of size n comma n filled with integers between 0 and 10 to the power 19. You can perform following operations on matrix A in any order, any number of times. And choose two integers 1 I and x and replace each element in row with the result of bitwise AND operation between x and that element. Formally, for every j, the element ij is replaced with ai and x. Or operation, choose to any two integers j and x and replace every element in column j with the result of bitwise or operation between x and that element. Formally, like you set this value. Different value of x can be chosen for different operations. Determine whether it is possible to transform matrix A into B using given operations any number of times, including 0. So, like looking at this, like the first thing this guy did was they looked at each bit independently. First, we can look at each bit independently. The idea is now we will have A matrix of 0, 1, B also a matrix of 0, 1. And we will choose x equal to 0 or x equal to 1. And we can check if this transformation is possible. And the idea is if we look at this for each bits we have in the number and answer is yes for all the cases, then we will print yes, otherwise we will print no. So someone has taken matrix as input and they've created a matrix A with trying to solve it for each bit. Now what they are doing is like they have counted how many zeros and ones exist in a particular column. And the idea is if you have not visited R and R as any one count, then you start DFS of R with I. Okay. Okay, like the question says, like you are given two matrices first. And there are something known as bitwise operator and an X. And an bitwise operator or. You start with some matrix A. You can choose some value X and apply bitwise AND operator here. Or you can choose some value X and apply bitwise or on all of these values. And you are given two matrix A, and your goal is to do some operations to get B and say it's possible or not. And that was the problem statement. And like in contest, like I was not able to solve it, so I am probably looking at other solution to see what they have done. Or any ideas in the chat? We can choose any value for any operation X. Okay, look something. Okay, let's probably look at Neil's solution once. Okay, what he is doing is like you keep doing like essentially DFS. If you have some alive row and column is also active and the value is and you mark it is empty. Okay, so this looks more like simulation. Okay, Neil's solution looks more like simulation here. We see like first we take AND with OR, right? A is the AND operator. So if some row exists and if the row is active, you just mark it as false. The active row means either the column is still alive or the value is 0 there. Okay, so like the way I think he's doing is do the operations in reverse. If I do it in reverse, or probably rather than reverse, like the idea here is let's try to do all the operations we have. We have this array. And let's say if I want to do it with AND 1, then what I can do with AND 1, what I am essentially doing is I am changing some and let's say AND 0 or 1. AND 1 I want to do. Doing with AND 1, 1 remains 1, 0 remains 0. Or it's actually the other way around. Let's say I want to do with AND 0 here. What we are essentially doing is like let's first make it 0 and then see will we be able to make everything as 1 here. We would be able to make like we will have two types of sequences here. Like doing AND with 0 will change 0 to 0 and will change 1 to 0. We are good here, and this is the bad operations. So the only way we can revert this is by probably doing or with 1 in this row. So the idea is like I first try to find one good row where I can make and with row 0, and that I can potentially do if any 1 to 0 conversion I make. I should be able to again revert that value to 1 by doing or on this row. So I try to find one row like this and I do an operation and 0 here. And once I have done some operation like this in this row, then my goal is I look at all the columns where I have potentially created problems and I will do or with 1 here. Or with 1, like 1 or 1 does not changes anything. 0 or 1 will again make it 0. So I am good here. And for this is a bad operation. So I will have to just check if I can do this so that I would be able to later do on and 0 over here. And that was the whole idea. Why this works, I probably does not know. That's why I was not able to solve it. But essentially, this was the whole idea. Knowing context, I did not solve E and F. So based on Neil's submission, what I see is first he started looking at each bit independently. So that for each independent bit of X, we decide what to do when. And when we look at one particular bit, all the value that particular bit will either be 0 or either be 1. So our problem essentially reduces to solving, checking if we can convert A to B on an array with 0 and 1 only. And now we have an array which is only 0 and 1. We have an array B which is only 0 and 1. The question is, how do we do it? The idea is we try to find one row where we will do AND with 0 while ensuring that all the 0 1 to 0 operations we do, we would be able to convert them back to 1 to 0 again if we need it by doing some OR operation in the row. If there exists such a row where all the bad decision can be reverted because we are not yet done operation on column, then we will apply that operation there. Once we are done with one of the row like this, then we will look at what all we can do with the column here. Now we want to do OR with 1, and the idea is again same. For any OR of 0 with 1, we get 1, but we wanted 0 bad operation. We have to ensure that we still have column of row operation in that row there. So like it's trying to do simulation. Find the one operation you can do and just go ahead and do this. Now assume that this will unlock few more operations for you later on and keep doing it like this. And the idea was at one point of time you will get A equal to B, then you are good. Or if you run out of all the operations, like basically the idea is you keep doing it on A as long as you can get. And the idea was you will either do AND on or only once in each row and in each column. And once you are good, done with all these operations, you just check whether your A become equal to B or not. And this was essentially the idea for probleming. Any questions, anyone? To be honest, I do not have a proof of why this works, but like that's what Neil has done here. So like this will definitely not really, because you see like this row alive you have initially true for all n plus m rows, and in every iteration you check if something has changed here. If nothing changed in E, you just break there. And in every whenever you make change to true, you make one row as false or not. So this loop will not run more than n plus m times. So overall the time complexity is nm square plus mn square, something like that. Like overall time complexity is, you can probably say n cube or whatever the constraints we had, max value of n and m. So like although this looks like while true loop, but there are only limited number of times when you can run this loop, because you don't make any change in a particular loop, you just break here and then you just check if this value is true or not. So that was the idea for problem E. I think I will also move to problem F. Like n multiplied by m is up to 10e3. So here the time complexity is n plus m multiplied by n multiplied by m. If you look at individually, these are up to 10 to the power 3. This will definitely TLE. But you see, one more constant was given, n multiplied by m will also be less than 10 to the power 3. So if you individually look at it, this component would be less than 10 to the power 3, and this would also be less than 2 into 10 to the power 3. And that's why it's not TLE. Okay, I think I will probably move to problem F. Recall that the rules of game name. Like there is a constraint here. Okay, there are up to 100 test cases. That's an interesting part. Okay, I think if I look at it closely, like can I say it minimum of n comma n instead of n plus m? Like 100 into 2 into 10 to the power 6 into 30 is around 6e9. Yeah, like log factor of bit is multiplied by 30. Can I say if nothing changes over here, then nothing will change over here too? And same goes vice versa. If nothing changes here, then next time this row will also not change. If we can claim that, then our complexity would be minimum of n comma n rather than n plus m. Then it would be minimum of n comma m multiplied by n into m into 30 bits. And when you have this, minimum of n comma m would be less than equal to square root of 10 to the power 3, which would be around 30 here, 30 here, and 1000 here, and 100 test cases. 1, 2, 3, 4, 5, 6, 7, which would be around 9 into 10 to the power 7, and can work here. I think like this is a fair assumption. Like if nothing changes over here, then why will some columns become active when you compare it with the last row? And if nothing changes here, then no more column will become empty for this loop. So this instead of n plus m, this loop is essentially minimum of n plus m plus some delta time there. And when you have minimum instead of n plus m or maximum of n plus m, then the things change. Now the minimum value of when n and m is less than 10 to the power 3, minimum of them would be less than square root of 10. Okay, problem F says, recall the rules of game name. There are n piles of stone where the ith pile initially contains some number of stones. Two players take turn choosing a non-empty pile, removing any positive number of stones from it. A player unable to make move loses the game. You are given an array A consists of n integers. Artem and Ruslam decide to play mnemon segments of each array. Each of the Q rounds is defined by segment L, R, where the element AL to AR represents the size of pile of stones. Before the game starts, Ruslan can move any number of piles from the chosen segment. However, at least one pile must remain. So, in a single round, he can remove at max R minus Li piles. He is allowed to remove 0 piles. After the removal, the game is played on remaining piles within the segment. Ruslan wants to remove as many piles as possible so that Artem, who always makes the first move, loses. For each round, determine the maximum number of piles Ruslan can remove. The number of ways to choose maximum number of piles for removal. Two ways are considered different if there exists an index I, such that the pile at ith index is removed in one way and not and printed modulo this. And if Ruslan cannot ensure Artem loses, then print -1. So game of pile, like essentially the problem reduces to you have a given subarray L to R. You have to remove maximum number of elements you can remove it from here. Another way to say is you have to keep minimum number of elements in this segment such that their XOR is 0 because the losing conditions for name is like XOR of all the elements is 0. And you have to also count for how many ways you can get that minimum 0 XOR here. That was essentially the problem statement we have. And I think my solution was definitely way too big here. We can probably look at what Neil did for this problem too. Like there were some observations I made, but my solution was definitely W. Hmm. Okay, first thing he did was if there is any element with 0 in the given range, you just print 1 and the number of zeros. You can, if you have any element 0, then you can just remove that element and make it 0. Otherwise, if you look at any number which appears 2 times, like XOR of two same numbers is again 0. So first you look at 0. If 0 exists, you just keep only 0 and delete everything. And the number of ways to do that would be the count of zeros. And the next thing is you look at two different numbers you have. If you have two same numbers, then you can keep those same numbers and delete everything else. And XOR of two same numbers will again be 0. So if in that case you look at how many pair of same numbers exist by looking at for each number the count it appears, and if any number appears you just print that count here. So you keep two numbers and you delete everything and all the pair of two numbers you get. So this was the easy part so far. Now we have the hard part where we know that now we have to keep at least three numbers here. So although this loop exists, but you can be sure that this loop cannot have size more than 50. So what someone Neil is doing over here? If you have some mask here, hmm I don't think I understand this one. Okay, folks are doing DP here. Mhm. These are up to 50 values. This best is up to 7 times. Okay, one more observation was like you don't need more than 7 8 values there. The idea is like probably you can look at Gauss elimination, like number of log of bits, you will definitely get an answer. That's fine. Interesting part. So like let's say we have removed all the duplicates. Zero exists. The case is trivial. Just keep zero. Two same number exists. Just keep these values here, and you can keep two values at max. Now you do not have any duplicate number in A to B. This essentially means like length of L to R would be less than equal to 50 because we do not have more than 50 values here, 51 values, but 0 also does not exist. And the idea was like values are up to 50. So you will definitely find a set of size 1 plus log of 50, which in this case is 7. Like there will definitely exist a value with a set with less than 7 values with XOR 0. Like probably I will avoid proof here, but the idea is like you can probably look at Gauss elimination and try to find how why is the case. The critical, like this was the critical observation, and now the idea is like we can have dp ix. We have taken I numbers, and their XOR is x, and you keep adding new values all the time here. And like for all the distinct values you have in this range, you try to update this dp here. And overall the time complexity was 7 into 67 number of different XORs here into 50 per query, which is around 8400, which is around into 10 to the power 5, which is too high, right? 6 7 8. I believe this can be still be too high. So why is this working here? Where is Anton? This is up to 50 values. This is up to 7 and 64. 7 into 50 into 64. 1 2 3 4 5 divided by 10 to the power 8. This looks DLE, but I'm not sure why did it pass here. But yeah, that's where we are. So this solution definitely passes here. I don't know why, but that's where we are. And any questions, anyone on this one? Like that's what essentially Anton did here. And looks like it has passed. Let me also see if my solution also works here. And I think I'm mostly done with the stream. Like I don't really have a proof of why Anton's solution worked, but looks like it did. And if it did not, then probably I don't have other solution either. So that's where we are. I don't expect it to pass, but if it passes, then it's great. So any questions, anyone? This can still TLE, I think, but I think I'm mostly done with this stream. It would be again TLE, I think. Okay, yeah, TLE. So yeah, I don't know how to solve F, and looks like I don't understand what's happening here. So yeah, I think that's where we are. Thanks everyone for joining today, and I think I'm mostly okay. Satyam has also solved it. Let's see what Satyam has done. Frequency zero exists. Print it. Mhm. Yeah, thanks everyone for joining today. And I think that's all I had for today. And any questions, anyone, with respect to any problem in today's contest or anything else? I think we ended up discussing A, B, C, D, E with no proof for E and no solution for F either. So thanks everyone for joining today. Mhm. I think problem rating, you can find it here. Okay, yeah. Preliminary problem ratings, you can find it here. NIM is okay. So like NIM is more than my rating and problem with queries as well. Yeah, like F is definitely looks like more than 2600, more than my rating, and explains why I do not have a solution here. No, like F it says 2600. So that is some average rating. Codeforces may have some plus 200, minus 200, something like that, but that's what it is. Like there is a reason why, like due to is rated up to 2100. Like I do well because a lot of people probably of my similar rating do not participate. If they do, then I would probably be back again for what my true rating is. Yeah, like Codeforces that will definitely cap that rating. Like Codeforces probably has formula of min of whatever rating their formula calculates and 2700, 2800 for due to. And like that explains why like only 6 people have AC on it. So this has to be higher rated. Like like now we have more people here, but yeah. So if we are just 6 people, then there are legendary grandmasters who have failed to solve this problem. So this has to be more than 3000. Yeah, looks like some fake legendary grandmasters as well, but yeah, there are legendary grandmasters who did not solve this problem. No, like by fake, I meant ki we have Santa Claus right now, so a lot of legendary grandmasters are not actually legendary grandmasters. You see on streaming. Yeah, like Rainbow also did not solve this. Okay, all the Rainbow code has been hacked. Interesting. Yeah, like Rainbow is definitely under 50. He has been to IOI 4 times. He was ranked 5 3 of the times. And in Hacker Cup, he was 6th and 12th. So he's definitely in the overall top 25. Like Rainbow is a guy who lives in United States who generally solves problem from hardest to easiest. So if he cannot solve the hard problem, he will not solve any problem. And that's why his rating is like this. He is definitely legendary grandmaster. That's because a lot of time he just solves zero problem. And if you look at his rating here, for example, when he solved zero problem, got minus 323. The only submission he has was on problem, last problem, or second last problem. Yeah, like that's how it is. So yeah, thanks everyone for joining today. And I think that was all I had for today. And I think I will probably end my stream now. No, I did not attend the global round late. I was trying to solve the hard problem instead of going usual A, B, C, D. Like it's not like I solved this on 24th minute and then I did nothing for next half an hour and solved this. Like I was trying to solve these problems. I could not solve it, so I just came back to getting some points. Okay, some tips. I think the idea is you can join my Discord server. The link is in the description. And then you can check here this channel roadmap to read in 2 minutes. Like here you can find one of the books which is competitive programming handbook. If you want some website, you can look at USAO guide, USACO guide. Here there are three divisions: bronze, silver, gold, etc. Like if you have just started, bronze is around due 4, platinum is harder than due 3. So whatever your current rating is, you can try to pick the topic and try to solve problems for those topics. And this also has some related problems you can, which you can probably solve here. So like this is an exclusive guide and it has a lot of resources. So you can check this and you can find more advices here. I think you can probably add me as a friend if you want to. Like for example, if you want to add anyone as friend, go to their profile, click on star here. Now it will show in friend setting. So I think that's all I had for today. And thanks everyone for joining today. Okay, Discord link. Like there should be a star on my profile. If you log in, you have to first log in and so that you are logged in. I think like for product of primes, I used that fact one or two times before, and probably let's say I just remembered it. And I think like probably the observation here was like you have to just look at three pairs LR, L plus one R, and L comma R minus one, and probably it works. So like 30 was something I tried to make an upper bound and just submit it because I knew it's problem D, so it should work. Yeah, like everyone just is just brute forcing pairs there. Or wait, I think three pairs may not work. Like I can try to construct a test case. Like let's say we call L as a number, mod 101 is 0, and L minus 1 mod 103 is 0 again. We can try to find one such pair, right? And then we can again pick R as a number which has mod 0. Or probably like I think I can we can probably try to construct a test case. L comma R, let's say GCD here is 5. L minus 1 R, let's say GCD here is 7. L comma R plus R minus 1, let's say GCD here is 11. So what we need is L mod 5 equal to 0 and L mod 7 equal to 6. You can find this using CRT, and you need R mod 7 equal to 0, and like I think you can try to come up with three conditions and like this, and I believe like these three pairs should not be enough. You will have to definitely look at more. These are not enough, and I think I can construct some test case for it given enough time. You can use like you can form equations using Chinese remainder theorem and get a test case like that. So yeah, thanks everyone for joining today, and I think I'm done for today.